Thank you everyone for joining me today. I'm very excited to spend some time with you to talk about enabling the digital government and next generation technology. First, a few administrative items. I'd like to thank you for taking the time to join me in my home today. Who would have thought 18 months later I'd still be in my home doing presentations, but welcome. I'm very glad to have you, and I'm looking forward to talking with you today. Three things administratively just to be aware of. I'm going to try and hopefully keep the noise down in my home, but it is possible. There's based on history, it's possible I could have one of three distractions. We do have a puppy, like many of you. We have a little puppy that runs around the house, so if you hear some barking in the background, just ignore it. Second of all, I have three kids at home, coming home from school, doing sorts of schoolwork, and the home printer happens to be in my office here. Despite my best efforts, people still print while I'm in here. So if you hear a printer running, chances are it's only a couple of pages of math. Just ignore it. And then third, if you hear a British accent, it's my mother-in-law. My mother-in-law lives with us. She's affectionately called Nanny. And sometimes she's a bit hard of hearing. She's getting a bit older, and sometimes she calls or yells looking for somebody in the house if she needs help with something. So if you hear a puppy, if you hear a printer, or you hear Nanny, don't worry about it. The noise will disappear. I'll just speak over it and keep talking. So again, enabling digital government, a very exciting topic. Digital transformation in general is a very exciting topic. And when I think of the different possibilities, different attributes of digital transformation, you can see them here in the chart. The one that actually excites me most is really enhancing the citizen experience. You think about how technology's evolved, about the devices that we have in our hands, the types of technology gadgets that we can get, and drones and cameras, and there's just so much out there that we can leverage and use to create better experiences. And enhancing the citizen experience is something, as a citizen, I'm very passionate about. And I think there's tremendous opportunity to look at new use cases, new solutions, new ways of serving citizens and offering different types of experiences in this great country we call Canada. A couple of examples and things jump to mind, many because of my own personal situation, is healthcare. For example, I mentioned Nanny, and she's getting older. She actually has some mobility issues, and the ability to do video-based healthcare, the ability to have smart cities, for example, and even figure out parking. When I take Nanny to the doctor or to the hospital for an appointment, for example, she has mobility issues, she has trouble walking, being able to reserve a parking spot, find a parking spot, not circling around, those types of things make a big difference. Even being able to do an appointment over video instead of her having to get up and go to a doctor's appointment. Those types of examples of better and smarter healthcare really have significant impact on us as citizens. Same thing with public safety. You think about sometimes terrible things happen, but our ability as a government to respond to those quickly, to have video analytics, to see people moving against the natural flow of traffic, and something happening that might be anomalous, to be able to see those types of things and leverage that data and that insight to respond just has tremendous value. Even analytics to look at video, to look at license plates, for example, be able to see where an offender may be traveling, and to be able to identify them earlier. There's just tremendous technology in the form of whether it's sensors and drones and advanced cameras, and when you can combine those together with things like 5G and IoT, which I'll talk about, you start to open up a whole world of new possibilities and new solutions and things that you can offer to citizens and offer as part of government that actually make the citizen experience better. And that can be better in the form of safety, that can be better in form of even digital experiences. And I'll talk to some examples of some of those digital experiences in a few minutes. A lot of the times we talk about technology, we get excited about technology. I'm guilty of that. I love technology. As someone who comes from a software engineering background, I get excited about it. I like to explore it and understand it, and just fiddle with the technology toys, so to speak. The reality is, it's not the technology itself that transforms things. It's not the technology that figures out the smart city. It's not the technology that figures out the new solutions for for public safety, it's people. It's people like you who are on this in this meeting, who are looking at different ways of innovate, different ways to do things. So I never ever want to forget that it is about people, and it's not just about figuring out those use cases. It's about transforming the way that we go do them. Just because there's a great solution around doesn't mean, hey, we can just adopt it. We have to change processes. We have to go figure out how to implement that into environments. We have other considerations as well, such as safety and governance and policy. So it's not as simple as, oh, there's a really cool technology, let's go do it. It's people driving transformation, driving change, and looking at how they can take the current environment and make a new and better environment, for citizens. So we never want to forget that. I'd say I'm going to talk about 3 of the 4 things that are on this page here to the right. I'm not going to spend time on cloud. There's been tons of conversation. There always is around cloud, cloud transformation, and I'd say that's another thing that isn't simple. I know there are many advocates in the industry say just shift to the cloud, go move to a cloud solution. But again, you've got to deal with security. You've got to deal with governance frameworks. You got to make sure that what you're moving makes sense at the right time to get the right kind of benefits and experience that you're after. So I'm gonna park cloud. I'm gonna talk about the 3 other things. I'm gonna talk about 5G, why that's powerful, because 5G isn't like 4G or 3G. It's transformational nature, and I really want to talk about that. I'm going to talk about MEC, or multi-edge compute. So think of multi-edge compute as combining the cloud with 5G, or combining the cloud with the network, bringing the network and the cloud together to get at new experiences, again, new use cases. And then in the case of IoT really is more about use cases, the examples of digital healthcare, or water leak detection, or fleet management. You're getting more into the IoT use cases and solutions. And to do IoT effectively, you actually need those other building blocks. So it's quite common to have IoT cloud, MEC, 5G, those things thought of together, because in order to deliver some of those broader solutions, broader citizen experience, you actually need the combination of those things. So let's jump into a little bit of the technology, and I do want to talk about 5G, the power of 5G, and multi-edge compute. There are 4 things, 4 sort of properties around 5G, and I think historically, when you think about mobile networks, you mostly think about speed. I think we've all kind of been trained that way. We think 3G, 4G is faster than 3G, 5G is faster than 4G. Yes, 5G is faster, so it does offer tremendous speeds, and I'm going to touch on speed in a few minutes. So much faster speeds, which absolutely means you can do more things. But there are other properties around 5G that are important. One of them is latency. So think of 5G, speed is just how much speed, how many gigs per second, megs per second. Think of as speed. Latency is kind of actually how fast the information arrives. So not how much, but how fast it gets to you. And that matters for things like, augmented reality and VR helmets, and, certain types of video interaction, and shifting compute, for example, off of drones into the cloud. So latency matters for different types of applications, and we'll get into that. So 5G offers a whole different ability to make commitments and guarantees around latency, much lower latency. So we'll talk what that means. And then density. You think about, many of us have probably done it. We've been at a sporting event, and, everybody's taking photos. Everybody's trying to upload a photo, send a video feed to one of their friends. And you often notice, hey, the performance is slow. You got to wait before it's uploaded, downloaded, etc. And that has to do with the technology. So 5G technology, massive input, massive output, as it's called. 5G enables you to have tons of users in close proximity with massive amounts of data. So that's new as well. And then slicing, think of this as prioritization. 5G also offers slicing. So you take speed, you take latency, you take density, you take those attributes, and you start to, in the network, control them, prioritize them, and you can actually have different levels of service. So, today in a 4G network, the network's the network, right? You get the speeds that you get, but in the future 5G, certain things, certain applications, certain solutions for, say, public safety, or control systems like navigation systems for drones. Different things can get different levels of priority, and that can be enhanced. Some things get better speed, some things get better latency, some things get both. So there's a whole bunch of new capabilities in the world of slicing that weren't possible before, and I'll give some examples of that as we get a little bit further into the material. First of all, 5G speed. There is no doubt 5G is faster than 4G. Today the mobile networks at peak will run in the range of a gig per second, peaking above, sometimes above a gig. Even on 4G, went into 5G today. The new 5G with the spectrum just released, basically, as we get into the high gigahertz, you can see the 4G, 5G in the second from the top. As you get into those speeds, you're talking speeds of 3 gigs per second. So you imagine a threefold increase in speed on the 5G network. And then in the future, with the next level of spectrum auctions, you're going to get into what's called millimeter wave when you get into these ultra high bands. And when you get into the ultra high bands, we're talking about jumping from 3 gigs even into the ranges of 10 gigs per second. So there's no doubt 5G is faster. There's a lot more speed. So there's a lot more we'll be able to view and see and do in near real time on the 5G network. So right now, when you think 5G, when it's fully deployed, it's running at peak, you think 3 gigs per second in the next few years. And then down the road, when the next level of spectrum comes out, we're talking 3 jumping to 10. So getting into some pretty significant speeds in the things that we certainly never had before, and things that, arguably we're not sure we're even in our mindset, 5, even 10 years ago. If you think about latency now, I want to shift to latency. Latency is really how fast information moves back and forth in the network. So I'm going to use the example of, say, a connected car or a drone. You want to be able to control that drone, say, remotely, or you want to, say, control a car remotely. You need to have really fast, really low latency. Information has to go back and forth really fast. And if you're watching, say you're driving a car remotely from another city on a screen or on a test track, those types of things, obviously we do and test. So you're driving a car remotely around a test track from another city, and if the latency is off, if the latency isn't as low as it needs to be, you can't actually brake quickly enough. You don't see the screen and what's happening fast enough, the video feed. By the time you then apply the brakes, the car might take an extra, 5 meters, 10 meters, 20 meters to go and stop. So that's an example of why latency is important. It's the same with, think of high precision mining, where you want to carefully extract some natural resources from the earth. You want accuracy. You want to make sure you're pressing the button and it's responding, instantaneously, basically. So that's what latency is about. And there's a few factors that kind of impact latency when you look at it inside a network. One is the 5G, which I just mentioned, right? 5G itself as a technology responds much faster. It's lower latency. So, from the tower to you as an individual, from the tower to a drone or to a piece of equipment, just from the tower to piece of equipment, the response is much, much faster on a 5G network than it is on a 3. So right off the bat, there's a big check mark saying latency is much improved. There's a whole bunch of new things you can do. Then it comes back to kind of 2 other factors. One is fiber. Fiber is still the sort of fastest and best technology available in terms of transporting information. It's why companies like Bell invest much money in fiber and putting fiber out to different locations, and obviously to our cell tower. So fiber is the next one. So the 5G network, you bring fiber right into the backbone and the connection of the tower. So fiber is really important because fiber's fast. It's glass. Light passes through it quickly, and that data can transmit through the network very fast. So the second factor is fiber. And the third one is what I'll get into, is multi-access edge compute. And traffic needs to get, from the drone to the network to something. And that could be to, a government data center. That could be to a, one of the hyperscalers data center. But the traffic needs to flow, and it needs to, sit on a server or be analyzed either in the field or somewhere in a compute environment. And that's where multi-access edge compute comes in. So the second piece I mentioned was the fiber. So I'll touch a little bit on the fiber. If you think about fiber, fiber is just super fast, right? So, you know, fiber with the right electronics, 100 gigs per second, and it'll be even faster in the future. If you look at the latency on fiber, it's sub 1 millisecond. Like you know, it's faster than you blink your eyes, right? So you're talking really fast performance over fiber, and so it's really critical to have a 5G infrastructure that's over fiber. You know, leverage as much fiber as you can, because when you decide to have your cellular tower, say on 5G, go instead of having fiber in them, you start to communicate cellularly or using microwave from tower to tower. Instantly slows down the network. So if you look at that second row in here, it's a millisecond if you run over fiber. It's 6 milliseconds if you use microwave and you kind of bounce the signal between towers. And then every time you bounce to another tower, you're actually adding another 4 milliseconds, another 4 milliseconds. So if you bounce back 4 or 5 towers, you're at 20 plus milliseconds. You've already lost just going from tower to tower versus that 1 millisecond over fiber. So really critical to have that fiber infrastructure, to have the low latency of the 5G. And then the third piece is MEC. And let me explain a little bit about what MEC is. Today, even connecting off a tower on 4G, or even the early 5G that's out there today, when you're on your cellular device, you got a precision piece of equipment. That traffic comes back over fiber. It goes into a central office. There's hundreds of central offices. It goes into a central office, and then that building goes to one or two different local data centers. Gets to a larger data center that aggregates all that traffic, and then it gets to the internet. So even over fiber today, you could be 3 milliseconds, you could be 35 milliseconds, before that communication gets all the way back to the internet. Say if you want to leverage something on the internet environment, you want to stream a super high definition video, or you want to do something on AR, VR. Now you're starting getting into ranges 35 milliseconds. It could be even longer, 60, 70 milliseconds, where it actually becomes very difficult to do augmented reality and other things, because it will actually make the user a little nauseous, a little uncomfortable. In the case of precision manufacturing or mining, the latency is getting a little too long, a little too slow. So what multi-edge compute is, it actually takes a mini instance of the data center and actually puts it inside the mobile network. So I'll use the example just because it's recent for me. In June, we announced a partnership with Amazon, with AWS, and we took basically a mini version of their cloud and actually put it inside our cellular network, inside what's called the RAN, the radio access network. So we basically pick up a little mini data center, we drop it right inside the cellular network, and that basically cuts away that 30, 35 or more milliseconds right out of the equation. So it's really like, your engineering equipment, your users basically connected instantaneously to the cloud and the cloud provider, or it could be a large government workload that we put inside the radio access network as well. But you're instantaneously connected. And when you think about that, let me tell you about some of the things that start to become possible. You think of something nice and audible, like the war museum, or the war the monument downtown. And you think about when they do the Remembrance Day ceremonies every year, you think if there was an opportunity there to do an augmented reality experience, so people who had headsets or mobile devices could just experience a richer experience as part of that ceremony. That would mean a ton of data. You would need it instantaneously with tons of people in that location. So that will be applying MEC to be able to do it really fast and get that non-glitchy, perfect performance. And you can start to create these richer, more meaningful experiences for citizens as they're part of different public ceremonies and other things. Another opportunity there with that low latency is actually one of the challenges sometimes with drones is the battery power. And the challenge with that is you take some of these autonomous drones or vehicles and have them floating around, and they're making decisions in real time based on the video feeds and the analytics they see. That uses up a lot of compute power, and compute drives battery. And so instead of actually having all the computing and all the analysis happening on the drone, you could actually just have it happen in the MEC node. It's zero. It's like it's connected. It's basically 0 milliseconds to have that drone connect into the data center. And so because it's connected, it's just like it's right there. You don't necessarily need all the compute power, the stuff that drains the batteries and everything else actually sitting on the drone. So that's a very different way of actually delivering some of these solutions, these use cases, a way that can be not just more cost effective, but a way it can have impacts on the environment, less batteries, less resources being used. You don't have to have as many chipsets and other things on some of these drones. You can do it in the cloud. And it gets to a kind of a better citizens experience through some of the things that are possible, but it can also have environmental impacts and benefits too. So MEC offers the ability to do these types of low latency things that really weren't possible before. You think again about densifying for more devices. I mentioned the stadium experience. We've probably all had it where, again, you can't upload that photo fast enough, or you're trying to send a video to a relative of a great sports moment. It doesn't work. Densifying, which 5G offers, the ability to really handle those high volumes. That is where something like the war monument or something would come into play. Being able to stream video, share video simultaneously to everybody who's in that close proximity, that close location, to have a virtual, meaningful virtual experience that kind of extends beyond the physical one that they're having there as well. So you need 5G to be able to have these types of experiences, and there's just so many of them. You think about some of the great museum assets we have as a country from coast to coast. There's so many great opportunities to just even enhance those types of experiences. All the wonderful tourist opportunities there are in different cities to have interactive and virtual maps to be able to preview and see things in real time, on your way even to going and seeing those events or those venues. So densifying allows to have those high volume, highly interactive experiences with thousands of people all in one place, which is not something that was possible before, certainly on 4G technology. And then when you combine all these different pieces, you got the pure bandwidth, all the speed, and then you take slice or latency where you can prioritize traffic, and then you add this ability to have high density and high volumes of people all in close proximity, being able to experience all this rich and immersive technology. Now with slicing, you can start to prioritize and control different features and different capabilities. So a lot of drones, for example, if they're not using video analytics, they just need geopositioning information, but they need it fast, right? So, for things like drones and air traffic control, you want the lowest possible latency, and you want to create a prioritization to get the lowest latency, and that's it, right? The bandwidth isn't the issue; it's the low latency. So you can create a slice for air traffic control type scenarios. Now, in the case of things like emergency services and emergency response, they should just be number one. So, hey, make that a high priority. So if you've got a first responder who's, at a very large event, make sure they're always getting great performance. They got fantastic, calling and video and immersive technology. Even if the general public doesn't get the same level of service, that's okay. They're first responders, top of the shelf, give them the best class of service possible. So those are the types of things that become possible with slicing. Some of them are even potentially, we're exploring that now. Some of them are even potentially dynamic. You could actually have a mobile device and start to control slicing and features on the fly. Those are, again, some of the things we're starting to look at now. Could I, go and choose, a higher level of service for a period of time because I'm planning on having a rich interactive experience or something different that I want to go do. Or, again, a first responder, hey, when they're on their first responder profile on their mobile device, they get that enhanced service. If they're using the same device for something else, boom, it drops back to normal service. So those are some of the things that are possible with slicing, and some more to come as we sort of explore the dynamic kind of end user control versions of what slicing can do. I want to shift gears a little bit because I talked about kind of the power of 5G. 5G doesn't look like 4G. I think of it a little bit like throwing, fuel on the fire. Just, when you throw fuel on the fire, it lights up brighter, see different colors. 5G does that, right? With all those attributes and the ability to enable. And again, people drive transformation, technology enables it. So the ability to enable all these rich and different experiences. When I think about IoT, though, I think about, the IoT solutions come to mind, like all the different use cases and fleet management and water leak detection. And I started to think, well, what if there was a simple way of doing IoT, called a catalog of IoT services? And I've been around IoT for a number of years, and I look and I see these types of solutions, and there's probably pages and pages of, I'll call it what's possible, or even what's out there, from smart traffic to parking to building, into energy management in buildings to water leak detection. I mentioned before, environmental monitoring. There's so many different I'll call it solutions and areas out there, and you can almost get overwhelmed by all the possibilities. And I think one of the challenges with a large catalog of solutions is they're not always consistent. So you can get a smart traffic system or a fleet management system, but back to what I said at the beginning, when you want to start to put these into the environment, you actually want to start using them in production for real use cases, real citizen experiences. What you have to be able to do is actually make sure they're secure, make sure they're managed, make sure it's clear what the operating procedures are around them. And that's one of the challenges we found, and I found certainly in the industry when it comes to IoT. You could have a catalog of 20 things, and the 20 things come from 20 different providers, different engineering firms who have figured out, I said, traffic or lights or fleet. And then when you've got all these different sets of solutions, okay, how do I make sure the company that does the traffic ones and the fleet ones and say the asset monitoring solutions, how do I make sure each of those companies, because they're often different ones, actually know what security means, and how do I make sure they know, to make sure they have the right security posture to support my requirements and the policies and procedures that we have in the organization. So it becomes difficult to bring together these different use cases, and I say bring together because the real power of some of these IoT use cases isn't just having, say, the fleet management on its own and the water leak detection on its own or parking on its own. It's actually when you can start to put some of these use cases and solutions together. If I can take some fleet information and combine that with some traffic information and combine it with, say, a driver scorecard, or I can actually figure out how to improve the safety of my fleet. I can figure out how to reduce the transportation time because I can route the fleet differently than I would otherwise. All these new solutions and new possibilities emerge that weren't there before. So a key focus that we've been driving, and a few others in the industry have been doing too, is figuring out, how do you reduce the complexity that exists within IoT? How do you create an environment that is a catalog, like I mentioned on the previous page, but that catalog has the security around it, has the management around it, and is really built more like cloud services. So, if you want to manage a truck or a trailer, for example, in the case of fleet, you can have it on a price per trailer. You can go online and order it. You can go on and track it. You can go and add a new tractor, add a new sensor on one of the devices. You could add the sensor yourself, or you could have someone come and do it. But building really a catalog and a management environment that allows you to really deliver on these different IoT services as a service, not as individual projects like often exist today. So if you're thinking about, okay, well, I want to enable smart cities, and I want to have a catalog of different use cases, but I want a single place to get those use cases, and I want it managed, and I have a certain set of security requirements, and I want it easy like other cloud-like services. That's the conclusion that we came to is required in the industry, and that's what Bell IoT Smart Connect is. It's something we launched earlier this year, mostly focused on supply chain and some of these fleet and asset tracking solutions, and now we're building new capabilities, more capabilities into it to make it richer and simpler. And why that becomes important is in combination, in particular, with what I talked about before with 5G and with MEC and these other things, is that they're all connected. If you think about this image here, the new smart ecosystem, the network, the cloud, the IoT use cases, security, all these pieces start to come really tightly coupled. It's very, very difficult to go and deliver a new video surveillance solution, one that does analytics, without understanding, okay, well, what do I need from a 5G perspective? What kind of latency do I need? Do I need MEC or do I not need MEC? Okay, well, what about the locations that are fixed that say it's not something that's going to run over 5G? It's going to be over a network that's wired versus wireless. Okay, do I have fiber there? What kind of performance can I get? To do things like analyze the data coming off the video analytics environment. Is that something I want to do myself, or do I want to connect it again with a cloud provider? So do I want to pick one of the 3 hyperscalers that has a good, analytics platform and use that analytics platform, across the fiber network or the wireless network, maybe with MEC, maybe not, to then go and analyze all this video. And is the video something that has to be responded to instantaneously, in which case, you need that really low latency, or is it something we can analyze and look at later? So the ecosystem and the building blocks become really, really important to go and put these new types of use cases and solutions together. So when you're thinking about, okay, how do I look at these different IoT solutions and use cases and opportunities to create different citizen experiences, certainly opportunities to reduce cost, to optimize other things that were on the slide at the beginning. But for me, I think enhancing the citizen experience is just a tremendous opportunity in front of us. But as you're looking at those types of things, you really do need the ability to really knit together these ecosystem, these building blocks that are on this page here, the IoT solution with the right kind of technology and platform underneath. And then, is it a digital experience you want? Do you want that single pane of glass to be able to manage and control these different IoT use cases and solutions? That is the simple way, and the way certainly we've become used to consuming cloud-based services. So why would IoT be any different? Like, why shouldn't it be cloud-based? Why shouldn't we be able to configure and control our services? So think about this ecosystem, a network, 5G, wireless, wireline, 5G MEC integrated together. It's connected into the cloud providers, the hyperscalers, to do that multi-edge compute. And then it's got this catalog of IoT use cases and solutions on top. So solutions, low latency on the network, connected to the cloud providers. So though the ability to bring that ecosystem together is actually what's going to make it possible to start to bring more and more of these innovative new use cases and solutions, to citizens, to government, to others in the future. So it's pretty exciting. It's different than what we did before. It's got a different set of performance attributes, and I think the more that we put in this ecosystem as a service, makes it easier to get it to citizens, to pilot it, to try it, to get it into production, really, to have the kind of benefits that I talked about around some of those examples of different experiences that are possible with the technology. I'd say a couple of things I would highlight, from a Bell perspective. Our goal is really to empower, our customers, whether it's, federal government and provincial, all the different governments, to figure out, how we can leverage different types of technology for you to do more. And that's about certainly, leveraging the network footprint. I mentioned we invest tremendously in fiber, tremendously in 5G, and we think about the sort of largest network and that foundation as a building block to build different IoT solutions, 5G use cases and solutions on. We're putting a big focus really on that IoT component, which you can see on the chart. A big focus, obviously, on 5G. A big focus on cybersecurity. I don't think anybody would shift or move into the IoT domains or into the IoT solutions and use cases without investing in cyber and cybersecurity. So we embed security into the IoT solutions and the use cases we sell for that reason. Tight focus on connecting with the major hyperscalers. I mentioned we've got MEC being installed into the mobile network now with AWS. We'll do similar MEC nodes with the other cloud providers as well. It's a multi-cloud world, so the network needs to be integrated with the different cloud providers. Obviously, continue to focus on what most would know the Bell brand for forever, which is voice and collaboration solutions, and then constantly evolving and making that internet footprint and the private networks that we offer much faster. So those are the building blocks, of how you create these new use cases and these new solutions. And really our goal in that is to empower empower customers, empower you to do more with the technology, and again, recognizing that people are the ones that lead transformation and change. The technology are really the building blocks, as I mentioned before. And then I did want to close by offering the opportunity, if you're interested, to hear a little bit more around some of the things I'm talking about now: autonomous operations, rethinking your security, the digital workforce. When I talk about collaboration tools and capabilities, and how do you shift and transform into these models. Some of the things our customers are talking about, other industry experts like Microsoft or others who are just spending time with myself, some of my peers, just talking about where the industry's going, things we can learn together. It's not about talking about the products per se, it's talking about experiences and what we're learning and how we share. So I would offer that if you want to hold up your phone and scan the image here and get some details there. It just sort of continues the dialogue and the story around what we're talking about as we speak right now. And then with that, I do want to thank you. I very much appreciate the time. I was glad I heard the printer a tiny bit. I don't know if you caught it in the background a little bit, but no puppy today and no nanny today. A little bit of printer, but nothing hopefully that distracted the audience. So I very much appreciate the time. Glad to spend it with you today, and thank you very much.